go ahead and fill in your side lengths. You are then going to solve for the diagonal. So I need you to solve, so if this is a right angle, obviously, then you would be solving for C. So use Pythagorean theorem, solve for C. Please put your answer in simplest radical form. It's important that you do that. Otherwise, it won't make sense what we're talking about today. So solve that one. Nope. You end up taking the square root of 200. Highest perfect square that 200 can divide by is what? 100. And so we're going to split this up into the square root of 100 times the square root of 2. So your answer should be 10 root 2 is equal to C. So we know that this side is 10 root 2. Okay, this is a special right triangle. When I talk about that, I'm talking about this right here. I'll outline in yellow. All right. So this is our first special right triangle of the day. Gives you 10, 10, 10 root 2. A similar pattern is going to happen every single time because this is a 45, 45, 90 triangle. You have 90 here. If you remember from a couple units ago, the diagonals of a square bisect the angles. So that would make both of these angles 45. I don't want that. 45, 45, 45. So you have a 45, 45, 90 triangle. Notice how it's 10, 10, 10 root 2. So to get the hypotenuse of a 45, 45, 90 triangle, all you have to do is multiply by square root of 2. You don't have to solve with Pythagorean theorem. This works every single time for 45, 45, 90. So we like this. We're going to jump into some examples. I think you're going to catch on pretty quickly. So if it's 45, 45, 90, so it's an isosceles right triangle, that's always going to be the case. This one, we're finding the length of the hypotenuse. First off, so it's isosceles. These two should be the same. So this one is also going to be 6. So the two legs of the right triangle, if it's 45, 45, 90, then those two are the same. The hypotenuse gets multiplied by square root of 2. So what's the hypotenuse? 6 root 2. So much faster. You want to memorize these because it makes your life easier. We like special right triangles. Next one. This one's a little bit different. So again, this is 45, 45, 90. Has to be because this is isosceles. The two legs are congruent. This side we'll call C for now. The hypotenuse is the leg. So C is the leg times the square root of 2. But our length of the leg is 4 root 2, so you are literally going to do 4 root 2 times root 2. Square root of 2 times the square root of 2 is the square root of 4. So we'll rewrite that as 4 times the square root of 4 What's the square root of 4? 2. So those square roots essentially just cancel each other out. So you get 4 times 2. So my hypotenuse is 8. So on some of these, you're going to have to do a little work to solve it out. It's not going to be quite as fast as the one we did right before this. Okay, and the last one, this page. This one, you're given the hypotenuse is 9 root 2. So what do the legs have to be? 9. So for a 45, 45, 90, it's the two legs are the same, and then the hypotenuse is just square root of 2. Cool, moving on. Let's talk about 30, 60, 90. We're going to do one where we solve with the Pythagorean theorem. It says on the right side a 30, 60, 90 triangle is formed when you divide an equilateral triangle in half. So we have an equilateral. On an equilateral triangle, all the angles are equal, and they have to add up to 180. So all my angles have to be what? 60. So these are all 60, including this one right here. And you have an altitude, the height. It says it's equilateral. It is going to bisect that top angle, making these making these 30. That's why it makes 30, 60, 90. And this one is also 90. Our job is to solve for the height. So this right here. We're going to use Pythagorean theorem right now to do that. 12 is C because it's across from the right angle. So let's use Pythagorean theorem to solve. I should see you write down 6 squared plus the height squared equals 12 squared. Please solve using Pythagorean theorem. Put your answer in simplest radical form. Go ahead and do that. This one. Because we're solving for A and B, but we're solving for a leg, you have to subtract 36 before you can take the square root. Just a reminder. So you're going to have to simplify the square root of 108. What is, anybody know, so have it already, what's the highest perfect square that 108 can divide by? 36. Because there's a lot, it can divide by 4, it can divide by 9. Multiply those two together, you get 36. So we're going to rewrite this as square root of 36 times the square root of 3, because those two multiply to 108. So your height is 6 root 3, because the square root of 36 is 6. So this is our example of why it works. I'm going to write it on the whiteboard just so you can see it really clearly. You have a 30, 60, 90 triangle. This one's 6, this one was 12, and then we just solved and got that this guy is 6 root 3. Okay, you can look up here. So the side that touches the 60-degree side we call X. So that's like your base almost. You're basing all the other sides off of that. This one just gets multiplied by root 3. A good way to remember it is that the side that is next to the 30-degree angle is multiplied by root 3. So 3, 30, they obviously have that in common. So this is X root 3. Take that side, 6 multiplied by root 3. And how do we get the hypotenuse? From this side. How do we go from 6 to 12? Times 2. This is 2x. 2 times this side, which is 60. You have this on the very bottom of your page. So the 45, 45, 91 is there, and then 30, 60, 90. So it's over on the whiteboard as well. If you look over by Cooper on that whiteboard. So again, x is the side, the leg that touches the 60 degree. That's like your base. The one that's multiplied by root 3 touches the 30 degree. And then the hypotenuse is always 2 times x. Double that. We're going to do one example of this, and we're just going to practice this. All right. This one is for sure trickier. All right. Find the values of x and y. Write your answer in simplest radical form. Right now you have the side that touches 30 degrees. Which one is that? Is that x, x root 3, or 2x? Look over here if you don't know, or look at the bottom of your page. The side that touches a 30 degree. What is it, Brennan? Is that the x, x root 3, or 2x? Right now I have 8. Is that the x, x root 3, or the 2x? It's x root 3. Oops, sorry. Which makes this one a little bit more complicated because you have to solve for x here first. So we're going to take this and we need to solve this equation. It's not necessarily a hard equation to solve. You got to divide by root 3 to get x alone. So that'll cancel out these root 3's. So you get x to be equal to 8 over square root of 3. But if you remember back to Algebra 1, we do not like having square roots in the denominator. And so you have to do what's called rationalizing. You have to multiply the top and the bottom by that square root. So multiply the top and the bottom by square root of 3. That'll get you 8 root 3 on the top. What does it give me on the bottom of the fraction? 3, because it's square root of 9. And what's the square root of 9? 3. So those square roots cancel each other out. So this has been rationalized. That is your final answer for the side length. 8 root 3 over 3. So that's x. To get the hypotenuse, you have to multiply by 2 times the value of x. So 2 times this side. You're just multiplying the top of the fraction by 2. So it would have to be 16 root 3 over 3, because that's 2x.